and that you've not abandoned me. All right, great. Thank you. All right, welcome to guys. I'm glad to have each and every one of you this morning, and I hope that you are doing well. So this morning we'll be looking at reflection of light from plane surfaces. Last week we looked at waves, the equation of waves, and how to handle basic calculations under your wave. I think that was all we did, and we solved more questions on wave that same week. I think we did wave and which other topic last week? There are two of them that will, okay, yeah, rectilinear propagation of light. That was our last class. That light travels in a straight line. We looked at eclipse, we looked at shadow, right? We looked at the pinhole camera, solve questions on pinhole camera, and the rest of them as regarding your the light travels in a straight line. Now we'll now look at reflection of light from plane surfaces, right? So now I'll be looking at your plane mirrors. Under plane mirrors, we have the laws of reflection. We have the images formed by a plane mirror. We looked at your inclined mirrors. We look at this. This has not allowed me to pronounce it. It's kaleidoscope, and then we'll have periscope, and then we'll have mirror rotation, right? So all of all of these things are what we're going to look at here. And the textbook I'm using for my reference is your senior secondary school physics, the one that was written by P.N. Okeke and Anya Koha. You know, there are two textbooks. I think we have new school physics. Who wrote that new school physics? Remind me, is it Anya Koha or PN? I think it's P.N. Okeke, isn't it? New school, the one that has nobody. You guys don't use textbook.
So, but I can't find the cover
Are you,
again.
are you serious? So the one written by the new school physics, the one that is a bit shiny, that has some portion of it colored very well, right? It's a bit colored. I think it's a new school physics, which was written by I think it's PNOKK. But there's one that they wrote together with Anya Koha, which is senior secondary school physics. That one, there's no much decoration on it, and it's ancient of days, and that's what I'm using. I inherited that textbook from my elder brother, and that's what I'm still using to date, right? So, and I cherish that textbook so much. So that's the reference I'm making use of for the classes. All right, so let's look at reflection. Now, last time we said that light travels in a straight line. Now, when light travels in a straight line, it keeps going that way unless there's an obstacle. Now, reflection happens to occur when there's an obstacle. Are you seeing it now? So when light strikes a surface, it is either absorbed, transmitted, or what, or reflected. Are you seeing it now? And there are two kinds of reflection. We have the regular reflection and we have the scattered or diffuse reflection. Are we together? Are we still together? Can you pin the two ties? Good. So now we have regular reflection and scattered. And now the kind of reflection you have is dependent on the kind of surface you have. If you have a smooth surface, you are expecting um the light to be reflected in one direction. Regular reflection in one direction. And it happens to occur when you have smooth surfaces, polished surfaces, or your example is a plane or a flat mirror. That's an example of an object that you're going to encounter your what do you call it, your regular reflection. So the light is reflected in just one direction. Why for this one, a scattered or diffuse reflection is the kind of one that the rays is reflected in different direction, and that happens with a rough surface. Example is your clothing material or paper surface. But what I want you to remember is that when you have a smooth surface, the kind of reflection you're going to have is going to be in one direction. You don't need to remember these names. What you need to know for your jam is what happens when the surface is rough, the kind of what happens to the direction of the ray, right? And when the surface is smooth, what happens? So if it is smooth, we're expecting that the rays be reflected in different directions, right? In different directions. And if the surface is smooth, we are expecting it to what? To be reflected in one direction. So these are the key things you are expected to remember, right there. If I draw the diagram here, I wish I can do that, but let me see. If you have this is your surface and the surface is smooth. Now, if we have an incident ray, when it enters, what happens? It bounces back. You have your reflection. Now, when it enters, the Lord give me wisdom to draw this. Let me not draw like Rachel. When it hits here, right, then it goes, yeah, I think I'm on point. Then let's have it again hit here. When it does, it reflects back this way, right? So let's have another right ray. Let's say it hits here, then it reflects this way. So you can see that this is the incident ray, right? The one coming down happens to be your incident ray, right? All these ones are your incident ray, and then this is your reflected ray. Reflected ray, I mean to say. And what happens, you can see that everything is happening in just one direction. Remember that what happens is that the surface is what? The surface is expected to be what? To be smooth. Now, but when you have a rough surface, a different thing is going to happen for a rough surface. So now what happens for a rough surface is that the reflection is going to be in different directions, right? It's going to be scattered. And I don't even know how to draw that scale. If you can just draw anything you can remember for the scattered, remember that when it comes this way, I have a light ray. Let's say when it hits here, what happens? We're not expecting everything to be going in the same direction. It can hit here, incidents can be here. Are we together now? Then the reflected cannot go the other way around. I can have something like this. Let's say we have an incident ray coming this way. Incident here. Then we can have the right ray going in a different direction. You can have another one here. Then this one can go in this direction. So just different direction. So remember that this is your incident ray, this is your reflected ray. The reflection can as well decide to move in different directions. So it's a scattered light. Remember the difference? Smooth surface and rough surface. I believe by now it must have sunk into your head, and that the Lord will help you to remember it. Now, the rays that strikes the surface are called your incident ray. Is that okay? So now the one that strikes are called your what? Incident what ray. You know these things already, isn't it? Is your incident ray, and why the one that is going off is your what? Your reflected what? Ray. So what is the laws of reflection? Right? How come I didn't complete this? So here is your incident. This is your refracted. Remember that this is your normal, isn't it? That straight line happens to be your normal. Now, the angle here, this is your incident ray, while here is your refracted ray. Sometimes I know I've seen questions where they will do a little bit of thing here to confuse you. They will give you the angle here and ask you what is the incident ray. What do you do? 90 minus that angle here, because the incident ray is the angle between what? The normal and the incident. The incident angle is the angle between the incident ray and the normal. So this is your incident ray. Please take note. Just subtract that very given angle from 100 from 90 degrees. This is your reflected ray, right? Take note, I've seen questions that way where they will just want you to confuse you a bit. They'll give you the angle here and ask you to find the reflected ray, right there. Now, which other concept or which other thing do you need to remember when it comes to the incident and the refracted ray? Reflected, Luther, not refracted. What is it? What do I have with the refracted ray? I'm doing reflection this morning. So now, the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. So that's one of the rules of reflection, that all of them will lie on the same plane, as you can see right here on the screen. Then the second important rule is that the angle of incidence is always equal to the angle of reflection. It is equal. That's the law of reflection. As long as we have this plane surface right here, which implies that sometimes they can give us an angle right here. Let's say they give us angle here to be 60 degrees. And they'll be like, calculate the incident ray and the reflected ray. So once you calculate your incident ray by doing 90 minus 60, automatically you have the value of the refracted ray. Does that make sense? So once I have the incident ray, automatically I have the what? Reflected ray, because what? The laws of reflection says that angle of incidence is equal to the angle of what? Reflection, right? So these are two key things you need to always remember at every point in time. All right. So that said, let's now look at a plane mirror, right? Now, our ladies will understand more. Well, some guys also do that of recent, there are people that spend so much time in at the mirror, right? Some of the guys that does that, you get a point now. But I don't even have mirror in my house. That's the funny thing. When I remember is when I'm going downstairs and then I pass my neighbor's mirror. I remember, okay, look at this place. You don't know whether you just look at it. Okay, nonetheless, I know come. Just like yesterday, I was going to church. I forgot that it's just my head that I brushed. I didn't touch the beard. I just left it. It was when I got downstairs. Look at the that side mirror, one of the windows there. I say, okay, no, comb your beards today. Time don't go. I leave and they go where they go. So, you get it. But I think, but let's understand more when it comes to display mirror because they take their time, right, to check the mirror. And that mirror you're using is a plain mirror, right? So, but there's this one they normally use as well that has that small mirror now. Again, you know that one now. That small one now. Uh-huh. Uh-huh. That has is it brown powder? But I think things have changed. Do they still use that brown powder now? It's circle and then it has brown powder on it. I think so. So they will just So now that one is a bit round and it cannot give you a full view, right? So now, but your plain mirror is the kind we have at home, the one that the ladies and some of the guys of recent that do fine boys they have, right? I think I did that when I was much younger, but I think the older you get as a guy, the more you pay less attention to. Not that you're not going to look good, but that extreme, I don't know, you wahala for your head. But I think when I was in secondary school, I was dragging the mirror and the powder with my people. I was even applying this gel. What's that black one? I was barbing punk back in the days. I used to carry punk back then. So you just apply it on the front of the hair, so you can look very nice for the ladies in the class. But that's a fact anyway. All right. So your plain mirror is the kind you have at home. And what happens? What kind of images are formed by a plain mirror? Now, if you check in the plain mirror, your left hand is your right hand becomes your left hand. That means it is what laterally what inverted. Right turns towards to left, left turns towards right. Now, another key you need to know is that it is the same size as the object. There's never a time you look at a plain mirror and then the size of my nose will not reduce. It is still the same size that I'm seeing. It tells me the size when it is getting bigger and when it is reducing. So it is still the same size. It doesn't change. So the mirror will not shrink the size. So the image in the from the plain mirror is the same as the object, and it is what virtual. You're going to see what a virtual image is all about. Then it is upright. It is erect. You've never checked the mirror and your head is upside down. Your eyes is not that of a child that was just giving birth, right? So it is still what erect, just like you are. Then it is as far behind the mirror as the object in front of it. So that same distance you give to that's exactly what the thing that it gives to you. So that's the images formed by a plain mirror. Remember, it is inverted, and the image is what produced by a plain mirror is what is virtual. The only thing there is that is what laterally inverted, that the right hand shows like the left hand side. But you also have curved mirrors that the objects in the mirror are closer than they appear. You see it on Keke now. People that you see that right up on the image, the mirror for your Keke and Pep and the rest of them, because that kind of mirror is a curved mirror, right? So it has different properties. They say that objects in the mirror are closer than they appear. So there are mirrors that when you go to that place, your face is now round. Your nose is bigger than normal. People like me shouldn't be going to that kind of mirror for any reason. Then another key properties around the curved mirror. You get the point now. So, but we're looking at your plain mirror. So what is a virtual image? It's simply the one through which rays of light do not pass through, right? Rays of light doesn't pass through it, but nevertheless, it is visible to your eyes, right? But rays of light do not pass through. But the real image, a real image is one through which rays of light can pass through. So images formed by a plain mirror is a virtual image. Check your past questions. You're going to see some of these things right there, right? And then why that one formed in a pinhole camera, that one we looked at the last time, is a real image, right? It's not an upright, it's not a virtual image, but a real image that is being formed in a pinhole camera. But for your plain mirror, which the one most of us have at home, the image is what is virtual and is what is inverted. Very, very important. Same size as the object. Nothing happens to the size of the object. It's still just the same size. All right. If you're still following me, can you give me a thumbs up very fast so that we can move with a speed of light? Beautiful. All right. So now there are other applications of the image that is formed. Now for this one, I think I experimented this when I read this topic back then. I experimented it. This image is formed by inclined mirrors. Now, if you position your camera, I can't see the back of my head. that my, what do you guys call it, that was trending online? In Igbo, we call it Opi. So I cannot see, my own is quite big anyway. In case you've not seen the back of my head before, it's quite big anyway, right? So when you bring your two cameras, right? You guys are laughing, yeah. But that was one of the things they used to yab me back in secondary school, right? That at some point I wish that schools will start swinging from the has cap. You don't just wear only, you have cap for your school uniform as well, so I can cover the whole thing from those guys. So now you can see the back of an obstacle. You can see an obstacle when you incline the mirror at an angle of 45 degrees. So this is how you place this one in front of you, then this one at the back, that you can now see the back of your head inclined at an angle of 45 degrees. Is that okay? So that kind of inclining mirrors helps us to actually what, see objects that we cannot see. A lot of applications about inclined mirrors, how you can incline your mirror at 45 degrees and the rest of them, right? And the smaller the angle between them, the more the images that are formed. You can have infinite mirror, infinite images, right? So the smaller the angle, the more the number of images that are formed. Does that make sense? Which means that when you have 0 degrees as the angle between them, what happens? You have infinite what images that are formed. We have a formula here. We have a formula right here for the number of images formed. So the smaller the images, the smaller the angle between the mirrors, the more images are formed. These are for two mirrors inclined at an angle. And the kind of mirror I'm talking about is your plane mirrors, right? So we have the formula 360 minus theta minus 1. So n is the number of images that are formed. Theta is the angle between the mirrors, which is always in degrees, then minus what? 1. So now imagine that the angle between the images, let's say we have an angle of theta equals 0. What happens? You have 360 over 0 minus 1. Anything divided by 0 will give you what? It will blow up your calculator. It's going to throw up an error for you, which means it's what? Infinity. So when the angle between two images is 0, what happens? It means that infinite images are what? Are formed. Is it infinite or infinite images? People that study English will answer that one. My own is I know what I'm talking about. So Infinite. So Titilola and others can pronounce it better. So then if the angle is 90 degrees, what happened? If you have 90 degrees, 360 minus 90, 360 over 90 minus 1 is going to give you what? 3 images. So if the angle is inclined at 90 degrees, we're expecting 3 images to be formed. Give me 2 seconds. Let me quickly check on something. I'm coming, guys. Just 2 seconds. All right. You know, in this country, you have to be alert, right? Before you be shouting infinite image, they'll come and carry you. Before I be shouting infinite image, nobody will come and you guys will just be there, right? So that's it here. So we have 360 minus theta, then minus 1. So if the angle is 90 degrees, we're expecting 3 images to be formed. 45 degrees, you can use that. So this is a very powerful formula that every one of us should remember, right? Every one of us, as long as this topic is concerned, should be able to remember how to form the number of images when two mirrors are inclined at an angle. And the smaller the image, remember, the more the images that are formed. At 0 degrees, infinite images are what? Are formed. Now, there are the applications of inclining mirrors. There are different instruments that work based on the principle of inclining mirrors. One of them is the kaleidoscope, right? It is a particular instrument. It has two. You can browse it, you can Google it to see what it looks like. But because our goal has changed now, we just need to cover as much as possible. Just know the whole thing. But I think it's important to just Google it and see what the images look like for the kaleidoscope. But the basic thing is that it has, in the tube, it has a mirror, and the mirrors are inclined at an angle, right? And there are pieces of colored image inside of it, right? So that when you look down through the tube, the pieces of those colored image between the mirrors, we are going to form 5 images, because the angle, who can tell me the angle between them for you to have form 5? Okay, it's already there. Is inclined at an angle of 60 degrees. I thought I didn't write that down. So let me see those that are following. So the angle between the two images are what? At what? At 60 degrees. So at that 60 degrees, we're expecting 5 images to be formed inside the kaleidoscope. So the angle of inclination between the mirrors in a kaleidoscope, if I'm pronouncing well, is 60 degrees. Are we together now? So these are some of those instruments that are used based on the application of what? Inclined mirrors. That when mirrors are inclined, that all of these things come into play, right? So now, very key, what brings about reflection is not the mirror itself. What brings about reflection is the shiny metal at the back of the glass. If you've checked your mirror before, right, for our ladies, when you remove that thing like carton, I think some of them will make use of carton, some of them might make use of something that will cover the back of it. When you remove it, you're going to see some shiny stuff at the back. How many of us are, if you've seen a broken mirror, you should have seen that before, right? So what actually brings about the reflection is that tiny layer of the shiny metal on the back of the glass. This is your UTME question, take notes. So that's what brings about the reflection, not the mirror itself, right? And there's usually a coating of paint to protect that very metal, right? So it's important to know that what brings about reflection. Yeah, green. Oh, makes sense. Justice. I think you're among those guys. You even know the color. Yeah, give me a thumbs up. All right. So it's not a bad thing to be among those. Yes, now you have to look good, Jerry. You have to check. Don't be like people that don't care. You have to look good, right? So that our sisters will be happy as well. Yeah, I know he's among actually. Yes, now, isn't it? The ladies, am I speaking your mind? Is that not so? You need someone that looks good, isn't it? Yes, now. Uh-huh. So not the one, not the one that when you are going to church, your husband will be in front, you will be at the, so that people will not know. Oh, all right. My people, let's continue. All right. So the next one is your periscope, right? A periscope is also an instrument. You need to get the one that you are proud to wait for him or her, so that you guys can walk to the church together. Right? You say you go, guys. That's my wife. So a periscope is an optical instrument used to see objects that are not in direct line of sight. Huh? Oh, sorry. When you guys are driving to the church. Oh, Titi, power. She said walk, okay. Oh, sorry. But you have to walk down to where you park the vehicle. You go fly, enter the car.
We'll park at the front of the church door, just have to climb the stairs and enter.
Oh, interesting. People, I see power. That's a good one, Titi. I like that. All right, so a periscope is an is an optical instrument. Money, yeah. That's why you have to study. You guys should study so that you will do courses that will bring in much money. Right? Is that okay? Yeah, study so that yeah. That's a good one. So a periscope is an optical instrument used to see objects that are not in direct line of sight, right? So it allows us to see over obstacles, to see around corners, right? Things that you can't see with just one mirror. So it helps us to see obstacles. Like I said, I use the back of my head as an example. That if I have two mirrors inclined at 45 degrees, do you know what I want to say now? 45 degrees Celsius. If you incline two plane mirrors at 45 degrees, right, you can see obstacles. You can see the back of your head. I think the one we did back then is one I and my elder brother did, if I can remember, when I was reading that topic. Something on how we can see the bottom of something without getting to check it ourselves, just with the mirror, without looking into it. There's how we did that. It's been a long time, and that's why I understood this very topic very well back then. So a periscope helps you to see over obstacles. It also helps you to see around corners, right? It is simply an optical instrument that helps us to see objects that are not actually straight up on the line of sight that we can't see when I look direct, but incline the angles at 45 degrees, you should be able to see them, right? So it contains what? Two mirrors inclined at what? 45 degrees. So it basically contains how many mirrors? Two mirrors that are what? Inclined at what? 45 degrees. All of these things, I feel you should be writing them down. You don't need all of the whole materials and the whole notes on the slide, because there are key points you should be putting down on your reading notes. I don't know if we are doing that. I know sometimes I don't give us chance to write things down, but I feel as I'm saying those things, you are putting down key things, especially the ones I wrote in red, right? So it contains two mirrors inclined at what? At 45 degrees. Now, what is the effect of rotating mirror on the reflected ray? What happens when we rotate our mirror? What happens when you rotate the mirror? What happens to the reflected ray? Now, when a plane mirror is rotated, right, the reflected ray rotates twice by twice that angle through which the mirror was rotated. Do you understand now? So let's say that I rotate the mirror by 20 degrees. It means that the angle of the reflected ray is going to rotate by what degrees? 40 degrees, because 2 times 20 is 40. So that's the principle or the effect of you rotating the mirror on the reflected ray. So when I rotate the mirror by 50 degrees, it is expected that the reflected ray is going to be what? 100 degrees. Yes, 100 degrees. I don't know why shells should keep coming to my head. 100 degrees, right? Which means that it is what? 2 times the what? The angle of rotation for your mirror, right? So that's the effect. So now if mirror is rotated through an angle theta, then angle turned by the reflected ray is equal to 2 theta. So you have 2t if you rotate your angle, right? Or rotate your mirror. So now the principle or the application of this concept, I wrote it in red, is the navigator secant or a mirror galvanometer. When I went to the question that Paul said, immediately I looked at it, I think I saw this particular question on this thing I wrote here. I think I saw it. I think it's one of those ones. Yeah, number 3. Which of these works based on the principle of mirror inclination? I'm coming to that past questions. I think Paul sent a good number of them, about 12 of them, that we are going to tackle today. So please pay attention and ensure you are writing some of these things I'm saying, and don't just be there seated and looking at me. Nikki Good Steve, I hope you are following, or you are trying to give a customer something. Hope you are following. Okay, interesting. Yeah, makes sense. Good. So now the um, result is made use of in certain scientific instruments, such as what? Navigator secant or a mirror galvanometer. So where do we make use of navigator's secant or the mirror galvanometer? We make use of that through rotation of mirror. While when it comes to inclining the mirror to an angle, you talk about your kaleidoscope, talk about your periscope. These are the two applications that are in your senior secondary school physics, because these are part of the reference textbook on that syllable, right? So based on rotation, you talk about navigator secant or the mirror galvanometer, and based on inclined at an angle, that's inclination of mirrors, you talk about your periscope, which is what? 45 degrees. And at 45 degrees, how many images will be formed? At 45 degrees, can someone work it out? If a mirror is inclined at 45 degrees, how many number of images are we expecting from a periscope? What's the number of images expected from a periscope?
7.
7 images, right? So we're expecting 7 images from a periscope, while we're expecting
Approximately
5,
8.
approximately 8 images. 360 divided by 45 is what? 360 by 45 is what? Science students.
8.
8. 8 minus 1 is 7. So where is the approximately coming from? Meso.
I did 360 minus 1, then divided by 45.
Have you not heard about your board mass? Division comes before subtraction now.
Okay. Yeah,
Yeah,
pass.
because if you want to solve that, it's something as 360 divided by, that's if you want to write it the way it should be, divided by theta, then minus what, 1. So you do division before subtraction, right? So very important, please don't make that mistake. Thank God I asked that question now. Before you go into the hall and then you pick 8, be like, oh, I finished work today. All right, so that's for that. So let's go straight to the questions that Paul sent to us. I'm going to import all of them at a go so we can get our hands dirty. Thank you for Paul for always being instrumental in terms of getting these questions. I'm owing you one sachet of water, right? And I hope you get the water and pay for it. Yeah, well done, brother. So let me forward to here so we can answer all of those questions. This period, I don't want to be keeping the class too long, right? So that you can easily visit the recording and don't feel overwhelmed. So let's leave it very brief. Let me send to Sysmo support. All right. Okay, so I think I forwarded. Let me import. Permit me to stop sharing my screen so that you guys will not see my secret. I don't have any anyway. I don't have any anyway. All right. So let's import all of them. I think I should do it one after the other so that I could have the right questions that we need. All right, guys. Yeah, so let's take it one at a time. Just one questions each so that we don't make mistakes. There are about 12 questions I'm going to answer now. All thanks to Paul. Then the ladies, how is the reading going? I have not been following up the messages on your group. The ladies, how has it been going? One person should speak up for you guys. Have the revision class.
I think you should pay attention to what is going on in that group. Because me, I don't even know what to say.
Okay, I should pay attention to what's going on. You guys have not had any revision at all.
None in the group, yes.
So you guys are just talking and making noise there. 1, 2, 3, 4. Hey,
It's noise.
I see the
like
1, 2, 3, 4.
I hope at least and then that is her name, Titi. She in the call.
Yeah, Titi is on the call. Yeah, she's there. Titi is on the call. So you guys should do something about it. I don't know why. When I 1, 2, 1, 2, 3, 4, 5. This is the 6th one.
So
I
let me
think
see
it's
my
important.
Sir, I would send messages to the group that they should reply so we can like fix a data, not revise, not reply. Let's not do it and send in our answers.
I can't hear you. I can't hear you. There's this harsh sound from your background. I can't hear you. There's this harsh sound from your background.
Okay. I said I'll send messages to the group. Nobody will reply me. I sent questions 3 times. Let's all do it and like send in our answers. Nobody did it. And
do you know whether maybe they don't know the answer now?
No, they are supposed to do it together. But now with my effort to make it.
And people planned to have like a revision session and all night something, and nobody has responded to that message. Nobody has said, okay, I feel this day will be convenient or this time will be convenient. But I don't even know.
Okay, please, you guys should do something. Okay, later I'll address that on our group later. Let's see what the challenge is. You know, women of Jerusalem, I don't know what is happening. I was thinking you guys are.
They should add us,
Justice,
guys,
you said?
to help out. Let them add us to the group.
Right. Ladies, do you agree? I should add them to the group.
Not that one. We have another one. Please.
Okay. So that the guys will spice up the group, isn't it? Justice, you are very funny. It is for girls only. Okay. Oh, good. So now you can see my screen. Confirm you can see my screen now. Everybody, confirm you can see my screen now. All right. So let's continue. I think I might need to zoom in on it, isn't it? So you can see very well. Yeah, so let me zoom in so that we can see the question properly. So question one says, can you see it now? If an object is placed between two parallel plane mirrors with the reflecting surfaces facing each other, how many images of the object will be formed? If the mirrors are parallel, right, between two plane mirrors, you guys can read now. Okay, Nikki, you cannot see? Nikki, can you see it now? You can't see. Can you log out and log in again? Try logging out and logging in again, please. I think that would help you. So send in your answers. Check that question, send in your answers. Everybody must respond at this point. So, hey, I think I showed the answer now. Infinite. Yeah, Nikki Silva, can you see it now? Can you see the screen now? Yeah, I nearly said, can you see the mirror now? Now, so it's infinite, right? Why is it infinite? Because if they are parallel, what does it tell you? That the angle between them is what? 0 degrees. Because if they are parallel, that means they are not inclined at an angle. They are just parallel to each other. They are not inclined. Is that okay? So now our answer here is going to be what? Infinite, right? Because they are parallel. Parallel means they are what? 0 degrees, right? So take note of that. Parallel entails they are what? 0 degrees. Now, the next one says, are we together? That an engineer, right? An engineer intends to deviate a light ray. I think I forgot to do that. An engineer intends to deviate a light ray from each part by 120 degrees, right? Are we together now? An engineer, I think I should be that engineer. An engineer wants to deviate a light ray from each part by 120 degrees through reflection from I think sometimes I forget I studied engineering. I don't know why. Sometimes I just forget. From plane mirror, right? So calculate the angle of what? Of incidence. Now, please, let's quickly put something on that our slide that I forgot to add. That's why I like solving past questions, so that places that my mind didn't go to. But I didn't see that particular one because this is how new school is senior secondary is structured. I think deviation came after this very topic, but let me just include it here. So now it's important to know that angle of deviation, take note, which I know we still have to take it down, but let me just give you now. Angle of deviation is the angle of deviation D is equal to 2 times the angle of incidence. Are we together? That's angle of deviation by a plane mirror. Sorry. Let me complete it, right? Angle of deviation by a plane mirror. All right. I hope we are following. So that formula for angle of deviation for a plane mirror, right, simply says that your angle of deviation to D is 2 times the angle of incidence. So which means that D is equal to what? Your 2I. So now somebody can go ahead and tell us the answer to that question, please. So what's the answer to that question? They said an engineer tries to deviate the light by 120, which means that 60 degrees. So just apply that formula and get your answer 60 degrees, right? So what did we use? We used that deviation D is equal to 2I, right? So deviation is equal to 120. So 120 is equal to 2I. Divide both sides by 2 divided by 2, so that the incident ray is equal to 60 degrees. All right. So the next question we have right here, they said, which of these works based on the principle of mirror inclination?
So
So
someone
which of the
asked
following
quickly.
works? Okay, Meso, go ahead. Your hands are up.
If we use this formula for angle of deviation, then what about this d equals to 180 minus 2i?
D equal to what?
180 minus 2i, because that was what I used to solve.
Yeah, it's that can work as well.
But I got 30 degrees and the answer is 60 degrees.
Now, angle of inclination in which line? Deviation in which line?
When an angle is tilted to one side.
Now, when it is tilted to one side.
Yes.
When it has to do with a plane mirror, can someone should check on Google for me again? Angle of reflection in a plane mirror. I think it's 2i. It should be 2i. Then that 180 minus 2i. Can anybody check? Someone should check. Just in 2 seconds. Thank you for bringing that up, Meso. Let's quickly check. The one I can really remember is the 2i. Anyone? What's that question again? Through from a plane mirror. Yeah, let's check again. Google it for me. What the formula do we use for angle in a plane deviation for a plane mirror?
Equals to 180 minus 2i.
For plane mirror.
Yes.
Good. So now, so when do we normally use 2i again? When do we
Let me
normally
check.
use 2i? Yeah, check for me, please. Man is getting older. Check for me again. When do we use 2i? 180 minus 2i for plane mirror.
So maybe the 2i is for angle of rotation, because you said that angle of rotation is equal to this thing.
Deviation equal to, thank you. Deviation equal to 2 theta. Yes. 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 Yeah, that's a better. Yeah. Deviation should be equal to 2 theta. Yes. So when we are trying to do rotation, it's going to be that that d is equal to 2 theta. I think I'm merging them again with that of rotation, right? I'm merging them again with that of rotation. Forgive me. Thank you, Meso. You see why it's good for others to read as well, right? It's also very important because I'm using, I didn't, it's been long. I just saw that question. I felt that, yeah, d equal to 2i, we're going to work for the deviation as well, right? But for your plane mirror, just like you Googled now, deviation is equal to what? 180 minus 2i. Unless you are doing that rotation, when then I ask the deviation for that rotation, it's going to be what? 2 times theta. Is that okay? I will sit together. A thumbs up, everybody, if you are still following. So that answer should be 30, please. Unless you're asking us about rotation. Is that okay? Titi and the rest. Titi, Lillian, Silva, Justice. Justice, are you there? Good. I think, is Titi still following? I bet she's confused. Okay, good. Very important. Meso, thank you for saving us, right? That's very important. So this is 2i, 180 minus 2i, please. That's with the deviation for a plane mirror in particular. So 180 minus 2i. And that's why Google is always there to help as well. Yeah. So deviation is 180 minus 2i. Makes sense. Yeah. We are good to go. So that should be 30, please. So apply that 180 minus 2i to what we're doing. So we're going to have is if you apply that rotation stuff, you get the answer is there waiting for you. The answer is there waiting for you, right? And then if you apply the actual formula, the answer is also there waiting for you, right? Thank you, Meso. I appreciate you. So deviation is 180 minus 2i actually. Yeah, so D will be 180 minus I is what again? I is one. I was 120, right? So I'm looking for I, Luther. So this is I right here. So this is 120 equal to 180 minus 2I. So 120 minus 180 equal to minus 2I. This is minus 60 minus 2I. So this goes so that I is equal to 30 degrees. All right, so that works. The next one now. So this one says, which of these works based on the principle of mirror inclination? So which one works based on mirror inclination? Which one works based on mirror inclination? Anybody answering? I think by now the answer should be raining on the chat. The answer should be raining on the chat by now. Anybody? Can we still hear me? You know, when it comes to question like this, nobody answers. You guys will turn to deaf and dumb. B. Do we agree for B? Do we agree for B? Everybody, do we agree for B? I'm having only Titi saying Emmanuel. Paul said C. Okay, let me go on the chat and observe what is happening there. Paul said C. Principle of mirror inclination. Are you sure you guys listen in class at all? Huh? Titi said B. Lillian said B. Nikki Gosiva said B. Emmanuel said B. Justice, what's your answer? I've not seen your answer here. Anointed. What's your answer? I'm having only Nikki, Lillian, Titi, Meso. No, Meso, I've not seen your own answer as well. Meso said B. Anointed said B. All right. So I said this before. When it comes to inclination, the two key examples or application highlighted in our text for the exam is your what? Cadiloscope, right? And your periscope. Now, but they said secant and microscope. Secant and galvanometer is for what? Rotation, isn't it? Secant and galvanometer is for rotation of the mirror. But when they are inclined, we are looking at your what? At B, which we explained earlier. So it should be what? The kaleidoscope, or how they pronounce it. Now, this one said, a ray of light falls on a plane mirror so that the incident ray makes an angle of 20 degrees with the, refracted ray makes an angle of what? Of 20 degrees with the incident ray. The mirror is turned about an axis to the right angles to the plane of the rays through an angle of 15 degrees. What are now the possible rays between the incident ray and the new refracted ray? So who is working on this for us? Who wants to try? Who wants to try for that question? Anybody? Paul, I will call names though. Meso, what's your answer? Paul, what's your answer?
I tried to work with it.
This question.
I didn't hear you.
Sir, this question is one complex topic on, I don't know, it's rotation of mirrors, and I've not really been able to understand that thing very well.
Okay, the rotation of mirror. All right, others can try. Let's.
I tried
Okay.
doing it,
But what happened?
I've not really understood it like that. I'm still studying it very well.
So the C you are giving me, is it the answer to the question? Or you're answering C for the last one we did? So you just change your, which one are you saying C? The current one. Okay, so can you unmute yourself and tell us why your answer is C?
I choose C because you said before that the incident angle is equal to the angle of rays reflected. So at the
Okay.
first place, when it was 20, then incident angle reflected should also be 20. And then when it turns to an
No,
axis,
no.
which
Remember,
is
they said that the reflection makes an angle of 20 degrees. Angle of 20 degrees with the incident ray. It makes an angle of 20 degrees with the incident ray. That's what they said.
Okay. So let me try.
Okay.
Since it does like that, it will now be divided by, I think, divided by 2, which will give us 10.
Okay.
Then the
For,
one
for
will be
which one?
15
For the incident
for the
ray.
first one.
Now,
Then
okay,
the one
good.
will be
So how
15 times
how, how
2.
do you get how do you get the 10 degrees for the incident ray? What's it? Let's kind of draw it.
2i
Everybody, I will
and
follow
then
you now. Everybody, I will follow you now. So we'll have something like this. Right? Remember that here usually is our incident ray, right? And here is our refracted ray. So now go ahead. Go ahead, Justice.
okay. Should I explain based on the diagram we drew?
Yeah. Go ahead and explain the diagram I do.
So I don't understand the diagram. I just guess that it's supposed to be 2 times. So 2 divided by 20 divided by 2.
Why are you doing two? Why are you doing 20 divided by 2?
I just use like 2i since this thing you can do 2 this thing to get how did you put that yourself? To get the reflected angle, you do 20 times, which is 40. You can also do 20 divided by 2, which will give you 10. Since it's
Wait, look at what happened. You know,
Okay.
they said that R and I is equals to 20.
Good.
And
Not
remember
arrow
that
and not arrow and. Okay, yes, and is correct. Go ahead. Go ahead.
is equals to 20. And now
Good.
we want to find I, the incident
Good.
rate. We will
Good.
have I equal to 20. That is the sum of R and I.
Okay, sum of I plus R is equal to 20. Then how does 2I now come in?
Because we want to find what do you call it? Remember that R is equals to I.
So that's for you. That's a salute for you. Is that okay? And that answers it. Now, Justice, have you seen the reason why the 2I works? Because they said that angle between the incident ray and the reflected ray is 20, which means that from here to here, the whole of here, from here through here, so I want to use a red distance so that we can demarcate it. I like that explanation that Meso gave. And that's what I want to hear. So from here to here is 20 degrees. That's what they're saying. So that I, right, plus R is equal to what? 20 degrees. But from the laws of reflection, we agreed that what? I is equal to R. So mathematically, the way we do it in math, anywhere I see R, I'll do what? I'll plug in what? I. So it means that I plus I is equal to what? 20 degrees. Right? Then Justice, I think we can now take it up from there. So 2I is equal to 20. So divide here by 2, divide here by 2. So Justice, now continue your explanation now. So I
so,
is equal to 10 degrees. Yeah, continue your explanation. Good.
so let me see the question. So since the other
Good.
one is pound, which is they rotated it will now be times, which is 15 times 2 to give us 30.
15 times 2. Why? Because when you rotate a mirror by what? Theta, what happens to the refracted ray? The reflected ray is going to rotate by what? By 2. Right?
Double,
So
yeah.
that makes the reflected ray is 20. Go ahead.
So let me continue. What has the possible angle between the 10 and the? I think you now do 30 minus that. I'm
Why?
10 or 20.
Meso, what do you have to say? Meso, what do you have to say? Paul, I'm coming to you. Meso, what do you have to say? Now, Teaching go on you. Okay. Now we've calculated the justice have moved further. Justice said that I plus I is equal to what? 20. Now you've explained why I plus I is 20. You gave him context that I plus I simply means that I and the reflected ray is equal to 20. Then we'll plug in to get the value of our I. Now he's trying to explain about the rotation, right? Because what they are asked to do here is we are asked to find the new value of the incident ray and the new value of the what? Reflected ray, right? So Nikki God Silva, are you there? Can you unmute? Nikki?
Sir?
The way you're answering, sir, that means you're not even here.
No, I'm listening.
You're listening. So what will be the next answer now?
Sir,
I'm coming. I've not called in on, so I'm coming. Emmanuel. So Nikki, what's the next step? How do we get, we've actually calculated the incident ray. So how do we now get the new value of the reflected ray, of the refracted ray and the angle of incidence? Okay, I think Justice has calculated the refracted ray already, and he said that it's going to be 30 degrees. So what will now be the new value of the incident ray?
Sir, truth to be told, I'm just coming now. I went to brush my teeth. I want to eat that.
Hey! Oh
I'm
my
hungry.
goodness. Oh my God. We have students in this class today. Titi, over to you. Titi, over to you. Congratulations. Titi, over to you. Titi Lola.
Yes. I'm worried. You said
Can you remove?
30, right? You said the answer I got is C.
Can you remove?
So
I think you're using a headset. There's this harsh sound from your background, and I don't think others can hear you. I don't think they can hear you because I can't hear you as well. So now, Anointed. Paul, I'm coming to you. I see your hands up. Justice, I see your hands up. Anointed, over to you. Anointed, over to you. Anointed, did this class at all? You are giving that your hand. I would have said let the hand break. Why are you giving me thumbs up? I'm calling you to give me answer. You're giving me thumbs up. This guy.
Okay.
Good.
Sir,
Yeah.
so since the angle between the incident ray and the reflected ray is 20 degrees,
Okay.
by the law of reflection, angle of
Yes.
incidence is equal to angle of reflection.
Okay.
So the 2i is equal to 20 degrees.
Okay. Then you have that I is equal to 10 degrees. Then we're asking now, we've moved past that stage. We are at the stage where we said that since they said the mirror is turned about an axis to the right angle to the plane of rays through an angle of 15 degrees, that the mirror was rotated 15 degrees. So now we're looking for the new value of the reflected ray and the new value of the incident ray. So Justice has actually mentioned that the new value of the incident of the reflected ray is going to be 30 because 2 times theta is equal to reflected ray. That will be 30. So we're now looking for the new angle of incidence. Do you have any idea on that?
No idea.
Oh, no idea. Okay, that's fine. Anointed. Okay, Paul, your hands are up. Can you go ahead now, Paul?
Sir, from the question,
Okay.
you saying the possible angle between incident ray and reflected ray.
Okay.
So I think the reason why we have two angles is because
Okay.
it's either rotated clockwise or anti-clockwise.
Okay. Go ahead.
So if it's rotated either clockwise or anti-clockwise, the angle of rotation will be less than the incident ray.
Okay.
Something like that. So I think for the first one, let's use maybe anti-clockwise. I think that one will be less.
Okay.
The distance between the original incident ray and the final reflected ray will now be the incident rate plus the angle of rotation.
Mm-hmm.
Then the final answer times 2.
Hmm. That's a very complex. You're on point, but that's a very complex solution actually. Not really complex, but then I don't think the other persons will understand, right? So
Then for
now,
the
look,
other
And
one,
can I go? Sir, can I answer?
Justice, go ahead. Let me hear your own view.
Based on
Please, I
what
want to talk. Oh.
based on what Paul is saying,
Okay,
I guess if it can go clockwise and anti-clockwise, it can either
okay,
be anti-clockwise will not be minus and clockwise will be plus.
okay.
Then you then do that this and that, which is the incident rate minus
But okay, go ahead. But do you think
for the
bringing in
okay.
clockwise and anti-clockwise which means confuse us? So why bringing in clockwise and anti-clockwise? Don't you think it's going to bring
Sir,
about confusion to some persons?
I want to say something there.
Okay, no, so go ahead. We have spent so much time on this
Um,
question.
for me now, I think that you say that the angle of rotation is twice the angle of
Good,
reflected. So it seems
good,
that the angle rotated is 15. Then 15
good.
times 2 give you 30. Then plus that
Okay,
initial angle which they inclined, which is plus 20, will give you 50.
good,
So
good.
that's the total sum.
No, no, yeah, that's the total now. But now you're not looking for the incident angle. Like after everything has happened, both of them is equal to 50. You're not looking for the new angle of incidence.
So it will be 10.
10. Beautiful. Now, based on what he explained, did you see what happened there now? After, okay, let me be writing these things down. I love the fact that all your ideas are connected, including that of Paul. But I want to avoid clockwise, anti-clockwise for some persons. Paul, I understand what you're saying.
Let me
Justice,
talk.
understand what you mean by clockwise and anti-clockwise. Mesa, you want to talk?
Yes.
All right, all right. The ladies have it then. Go ahead.
Okay, I think the what is it called again? The mirror is rotated like
Okay,
15 degrees away from the
okay,
incident because mostly
okay,
what we are talking about here is incident. So I feel
okay,
the mirror will be rotated away from the incident. So it will be going from that normal, it will pass the incident that is going to that line that is down.
okay,
So what we're going to do is that we're going to add it to this new incident angle that we have.
okay,
So it will be 15 plus 10. I think yes, 15 plus 10 to give us a sum
okay,
of 25 as new incident angle. And remember that 2i, 2i, like to find the normal incident, just one incident, we have 2i, just like we did with the first one, 2i equals
mm-hmm,
to 2. So we can still
mm-hmm,
do 2i equals to the sum of equals to, wait, let me check what I'm 2i equals to, yes, equals to 25 times 2. That is that 2 because the new incident angle is 25. That is sum of 10 and 15. And that's how we got 2 times 25 equals to 50. I don't know if you got my point. Hello?
No, you tried,
So sorry, guys. I lost my internet. Sorry. Can you hear me now? Okay, great. So make sure you are on point. But then look at what we're going to do. Since we need two values. Paul. Now your idea of clockwise and anti-clockwise is very, very, very okay. Is that okay? Now, but I think the best thing we can do is that it is possible that the angle after the rotation, it's possible that the angle can either increase or decrease. Is that okay, guys? So everybody, you guys are on point. And we are
He's on network. Yeah. I mean, someone should tell me what that alakoba again alakobani, what it means. I beg.
Okay, it has
Alako,
different meanings. Okay, Paul, explain or anybody. Who wanted to explain now? Explain, please.
Alakoba is
Calling
actually
troublemaker.
no, Alakoba is not troublemaker now. Alakoba is actually someone that puts someone in trouble.
Yes, exactly. Not even like in trouble. Like Akoba can mean different things. Like might be that you are disgracing the person or doing it. You understand, Sha?
In my language, akoba means money. Paul, can you continue with that your clockwise and anti-clockwise before the teacher comes in? I beg.
Does anyone have this physics textbook? All inclusive calculations in physics. Does anyone have it? So you can check the rotation of plane mirrors. It's very explanatory there. Well, what that question was saying was distance between incident ray and final reflected ray. Because the thing is, the reflected ray, the angle of the incident ray, I mean, doesn't change. It's just the reflected rays that changes. So since the I is constant, that's the incident ray. So we have R1 and R2. So R2 is the final reflected ray after the mirror is rotated. So I think if it's clockwise, the value of the angle will be, I think, positive or so. I'm not really sure about it, but there's a way where
My
the
internet cut me
angle.
off.
Okay, it's back. So
Yeah, Paul, thank you for taking over. God bless you. You're a good guy. hope you explain it to them. Eh? Paul,
I did not finish.
you've not finished. Oh, go ahead and explain. Go ahead. Why I connected with the other one. Go ahead.
Okay. So there is the what I was saying was, so to find the distance between, or the angle between the incident ray and the final reflected ray, it will be double of I plus theta. Theta is the angle of rotation. So because the angle of the distance between the angle between the um first reflected and reflected ray is I plus theta. That's the distance between them. So if you are to find the second one, the angle between the incident ray and the second reflected ray to be double of I plus theta. That will be 2 into bracket 2I plus theta. But if the angle of rotation is less than the initial angle of incidence, that is, the theta is less than I, so it will now be 2 into bracket theta minus I. So that's why we have two possible angles. So it can either be I plus theta or theta minus I. So if it's I plus theta, we'll have 50 as the first one. Then if it's theta minus I, we'll have 10. So that's why we have 10, 15, and the rest of it.
Do we understand what he was saying? I think you guys should understand what he's saying, isn't it? So the major thing has been done already. If you can get this, the only challenge I was thinking we are going to have is calculating the incident ray and the reflected ray. Are we together? Can you hear me now? Confirm you can hear me now. Hope my network is stable now. Good. So two things can happen. Either it decreases or increases. Are we together now? It's either the angle will do what? It's either it increases or it decreases. Are we together? Increase or decrease. So 30 by 20 gives us what? 50. 30 minus 20 gives us what? 10. So it can either increase or it decreases. That's how I want you to remember it, right? So Paul have explained wonderfully well, right? In terms of, yeah, you can go with clockwise, anti-clockwise. If you actually understand the concept, I'm talking about those that might be confused with the clockwise and anti-clockwise. Just know that the angle can either increase or decrease, which is the same concept as clockwise or anti-clockwise. Everybody, I think we're okay now, isn't it? Everybody, okay. If you don't understand what Paul said, I've given you a shorter way to always remember. Anointed, Titi, and the rest of them. Yeah, Titi and the rest of them. Hope we're good. All right. So that's how the class should be. I mustn't be the one talking at every point in time. I'm glad my internet did that, so that someone can explain from there, and that's how it works. So feel free anytime for you guys to always fix classes for yourself and learn together. That works very well. All right, so the next question. Titi, do you understand it? Anointed, do you understand? Who again? Lillian. If I call your name, give you a thumbs up. If you don't understand, let us know. Lillian, are you there? Do you understand what we're saying? Nikki God Silva, do you understand? Who again? Another person I've not mentioned their name. Yeah, so let's continue. So that question has been answered. So either increase, decrease, you add, or you subtract, or you go clockwise or anti-clockwise, just like Paul and the measure have highlighted. So anyone that works for you is entirely fine. So they said a mirror is rotated at an angle of 30 degrees. If the incidence ray has a constant direction, at what angle will it be reflected? That one is as simple as anything. So I think the only challenging question now that might be confusing for some persons is that one you answered. But with that one, you can answer another question. So what's the answer to this one? C. Do we agree? Do we agree, everybody? Do I agree with Titi on C? Meso and the rest, do we agree? Lillian? Sinonso? Other persons are not following. I think the only people following here is Paul and the rest. I actually agree with pointers of clockwise and anti-clockwise, plus or negative. Okay, that works entirely. So what's our answer, guys? Any other person? Can we move to the next? Nobody's answering again. Meso C. Okay. All right. Beautiful. When a plane mirror at which an is rotated to an angle will be what? We have done this already. So you all should answer now. Yeah, Titi, you are correct. Why they are not answering is that they are now big guys, they understand it already. You get so now, so it is 30. Let me just talk about that. If it is 30 here, we always know that it's 2 theta now, right? We always know that as a constant at what angle will be rotated. We know that once it's rotated, R is going to be what? 2 times theta, right? So that's why we're not some of them are not talking again. So the same question over and over again. Are you seeing it now? So for plane mirrors, they don't have much to ask us. So we still have the same thing right here. The next one. Incident ray of light strikes a plane at an angle of incidence of 35 degrees. If the mirror is rotated through 10 degrees, through what angle is the reflected ray rotated? Oh yeah, get your hands dirty. The same concept, guys. Get your hands dirty. The same concept, guys. Do I have people working on that? Do I have people working on that? Mona, they respond. I will only be there for the call. Okay. A, okay. Check very well before you tell me A. Check very well before you say A. Check very well before you tell me A. Right? I'm not saying you are wrong. I'm just saying you should check very well. But I'm not in any way saying that you are wrong. Any other person? Or do we all agree with A? I love the way this class is going. So you guys can stop questions more instead of me saying and answering at the center. So what do we have? So who is going? That means no, you might not be wrong actually. Another person should go. Another person? I think it is D. Okay. All right. So Paul. Now I will call two persons that produce the answers. I have Paul saying the answer is D. I have Emmanuel saying that the answer is A. So do we have people supporting Emmanuel? Titi said, okay, that means okay, A. Paul said D. Another person? I need two more answers. I need two more answers. And I will call in names. Lillian, Meso said A. Okay, Meso is supporting also. Lillian, Nikki got Silva, Anointed. Nikki got Silva, Anointed. Princess. I think Princess this is the first time I'm seeing you in my class. I've not seen that name before. Anointed said,
Yes,
"Yeah,
sir.
I've not seen you in my class
I'll
before."
do.
I didn't hear you. You said
I said
you
I'll pick
picked
D, sir.
D. Okay. Now let me pick Paul. Defend your people for D. Emmanuel, defend your people for A. Go ahead. Paul, you go ahead now. First one, Paul.
So if you are to follow the normal this thing, the angle through which is reflected, that is after it has been reflected the first time for the
Okay.
first reflection, when it's
Mm-hmm.
rotated, it will be reflected
Mm-hmm.
through another angle. So
Mm-hmm.
that angle will be the incident ray plus the angle of rotation.
Okay.
Since the incident ray is equal to the first rotation angle of first reflected ray.
Okay. So in
So the
summary, you're
second
saying
one will
that
be
okay, go ahead. Go ahead. Continue.
second
Finish
reflected
up.
ray will be I or R plus theta. That's the 10. So making it 45
Okay.
degrees.
Making it 45. So what you are trying to do, you first of all calculated your reflected ray from the incident ray that was given to you,
Yes, that's 35 degrees.
which is 35 degrees, and then you now connected it to your incident to your angle of rotation, isn't it?
Yes, sir.
Okay. So Emmanuel, can you defend your people for A?
Almost. You don't fail.
Feel free. You might be correct. You never can tell. So defend your people for A. If you cannot defend
Sir,
for people for A, Meso can defend for you guys.
sir, normally I just use the normal principle that we have been taught. So concerning the this
Okay.
thing, the angle
Okay.
reflected. So if the mirror is rotated through angle, because the angle rotated is simply just twice the reflected angle. So that's what I have to
Mm-hmm.
use.
Okay.
That's
So
all.
Meso
That's
now.
simple.
Okay, because Tino is shaking a bit. Meso, what do you have to say?
The formula I used is angle of rotation of reflected rays equals to two
Mm-hmm.
times the angle of rotation of the mirror, and the angle of rotation of the mirror is 10 degrees. So I did 2
Okay.
times 20.
Okay. So which means you had no business with the incident ray.
35. No, I had no business with it.
Okay. Now, um, okay, Meso, you messaged me on WhatsApp. What is wrong? Oh, thank you for that. My internet went off then. So now, Paul, just to add to this, Paul, that incident ray is a distraction. You don't have anything to do with. Are you listening now? There's no connection. Once it's rotated, our business, they didn't say, I didn't even mention that the angle is between the incident ray, the angle between incident ray and the reflected ray is so and so. Do you get the point now? But there's no connection between the both of them. It's just on its own. So all we know is that regardless of whatever thing that was given to us, we know that if the mirror is rotated through 10 degrees, something happens to the reflected ray. Do you understand? It's going to rotate by what? 20 degrees as well. Or are we together? Sorry, let me join in. Paul, do you understand what I'm saying? Good. So don't get confused about that incident ray, right? It's just an extra information just to trick our head, right? So that means that the answer here, please, if you don't know the answer, when I call your name, please respond. There's a reason why I'm calling your name. Are we together? Even if you don't know the answer, when I call you, respond. So I know who is following and those that are not following, whether you know the answer or not. All right. So Nikki, I know I've called you 2 times, no response from you. Lillian, I've called as well, no response. And Anointed as well. So please, anytime I call you, respond. Now look at this one. We've answered this one. Okay, this
So
one we've
wait,
answered now. Okay. Is that
so
Paul?
angle between. So I have a question.
Okay.
So angle between reflected ray and incident ray
Mm-hmm.
is different from angle of reflection.
Yes, because look at it here.
Okay.
You get a point. So now here, if they say, sorry, this is not the center. If they say angle of incidence, right? 35, it means that just here is 35. Where you now have to do something is when they are saying the angle between the incident ray and the reflected ray, which means the whole of the both of them. Like from here to here, look at the English I'm speaking, the whole of the both of them. So now, but it's correct now. So from here to here,
All right, sir.
you understand the hair. Boy, you want
It's
to
just
pull me into look at
that
the kind of grammar. It's just a
the
lot. Go ahead.
numbers are confusing.
Yeah, it can be
So,
confusing at some point, but just always remember that that one. Let me speak down my English again. The whole of the both of them is angle between. If you have the angle between them, incident and refracted ray, you bring them all together, right? So the whole of the both of them, yeah, good. Lillian, if you laugh, I block you. All right, that's for that. Look at this one. An object. Mercy, you're laughing. An object is placed in front of two plane mirrors, inclined at an angle of 0 degrees. If the total number of image formed is 7, find the value of theta.
sir, 45.
45, 7 images.
Yeah, I've
Do
done
I
it
agree with
before.
you? You've done it before, right? And remember that. Okay, let's solve for the case of those that. And I've said that periscope is 45, and we can. I think yeah, both of you did that. You and Meso said 8. Why you said 7? So remember how we're going to do this. But this question, do you know that this question is not meant to be solved to save time, like on the exam condition, because they want to remember the idea of your periscope, which is what 7 images for 45 degrees. But let's check. If I'm looking for theta, I have that n is equal to 7, 360 divided by what? We are looking for theta minus 1. So this is 7 theta cross multiply is equal to 360 minus 1, right? Then I have 7 theta minus 1, sorry, plus 1 equal to 360. I'm looking for the angle, isn't it? A thumbs up if you are still following me. Can we have a thumbs up? Can you see hear me? So now this is 8. I believe you guys are following actually. Wait, can I do this way? No, this is not possible. This is not possible. This is 7 over 1 equal to what? 360 over theta minus 1. This is something I say minus 1 over 1. So now, that said, I want to get the answer right here. So what am I going to do here? So let's simplify. But on the exam condition, we don't have to be doing this actually. This is theta minus theta over theta. So this will give us 7 is equal to 360 minus theta all over theta. In exam, I'm not doing this. I say it again, we're not doing this in exam. So this is 7 theta is equal to 360 minus theta. So 7 theta plus theta is equal to 360. 8 theta equal 360. Divide both side by 8. So that theta is equal to 45 degrees. Do you understand? Do we understand? Do you understand how we got that theta 45 degrees? Yeah, so you always solve, right? Don't make the mistake of moving one the other side. Just solve the fraction first. This is a fraction first. So simplify it and then get your answer. So that being said, Nikki, are you following? Good. Lillian, are you following? Lillian, are you following? Good. Right, but know that 7 images is 45 degrees. Then 60 will give us how many images? 60 should give us 5 images, isn't it? 60 should give us 5 images. Then 90 will give us 3 images. Just that way. Always remember this thing so that it will save you time in the exam hall. Now they said, if a man stands symmetrically in front of 2 mirrors which are placed side by side at an angle of 72 degrees, find the number of images formed. So who is solving? Find the number of images formed. Who is solving? Fast, 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 fast. Who is solving? Meso said 4. Okay. Who again is seconding Meso? Who again is seconding Meso for 4? Who again is seconding Meso for 4? You guys should save me this energy of talking and talking now. Respond. Eh? TT4. Nikki, talk now. Lillian, talk. What is this? What's her name? Princess, Justice, Anointed. What's your answer? Emmanuel. Stop using D for me because I'm not looking at this thing. Okay, D is 4. Okay, Anointed said 4. Meso said 4. Titi said 4. So it's more like each special angle has a common difference of 2 for their number of images. Okay, 4. Did you see what Princess typed on the chat? Did you guys see what Princess typed on the chat? That it is more like each special angle has a common difference of 2 for their number of images. And do we agree with that? I don't think I do actually. Because at angle 60 degrees, you're going to have 5 images, right? You're going to have 5 images. And at 90 degrees, let's check whether that rule is correct. And at 90 degrees, you're going to have 3 images. Yeah. Yeah. Then at 45, you have 7. 2, 2. Okay, makes sense. Well done, Princess. That's a good observation. A very powerful observation. All right. So just you observe what she said, right? That's a very good observation. That for your special angles, the images is going to have a difference of 2. And if you check that, that is true. At 45 degrees, you have 7 images. Let's start from 90. At 90 degrees, you have 3 images. At 60 degrees, you have 5 images. At 45 degrees, you have 7 images. Then at 30 degrees, you're going to have like 11 images. Which alters what? Which alters it actually? Which alters it because 30 is also a special angle. Princess, are you there? Yeah, have you seen that it alters it at 30 degrees? All right, so we don't get to cram it that way, right? So we don't make mistakes. All right, so the answer to this one is simply 360 over 72 minus by 1. So 360 by 72, my people, will give us 5. So 5 minus 1 equals 4 degrees. All right, I hope everybody's following anyway. Now, the next part of the question says, a ray of light falls on a plane mirror so that the reflected ray makes good. Paul, have you seen it now? That kind of thing you are looking for, you've seen that they brought it in. So it makes an angle of 20 degrees with the incident ray. Are you seeing it now? The mirror is now turned about an axis. I think this is the same question. This is the same question. Nikki, your hands are up. What happened?
So why are we minusing it 1?
Yeah, that's the formula. The formula is n. Number of images is 360 theta minus 1. Yeah, that's the formula. All right, so I think this is the same question we solved earlier. I think it's repeated. A man stands 4 meters in front of a plane mirror. If the mirror is moved 1 meter towards the man, the distance between him and the new images. I like this question. So now, remember what we said about your plane mirror, right? So they said a man stands 4 meters in front of a plane mirror. If the mirror is now moved, you're moving the mirror 1 meter towards the man. The distance between him and his new image is what? Meso said, let me look at the options in the charts. Meso said 5. Paul said 6. Okay. Paul said 6. Justice say 5. So why are we 5? Nick, I'm confused. Why are we 5? How? Sorry. I'm confused.
I'm sorry, the answer is 3 meters. I beg.
Who is talking now? Justice.
Yeah, just
Okay. Paul said 6. So Paul, I want to know because okay, anointed. Okay, let me use anointed. Anointed said 6, which is correct, right? And Paul said 6, which is also correct. So anointed, I want you to tell us why, tell this humble house why the answer is 6.
Okay. So initially,
Mm-hmm.
the man is standing 4 meters in front of the plane mirror.
Okay.
So his mirror image is formed 4 meters behind the mirror. So total distance
Yes.
between the man and this image is 8 meters.
Is what?
Total distance between the man and his image is 8 meters.
Mm-hmm. Yes. Yes.
So the mirror, if the mirror is moved away from the man, that is one. I mean, is moved towards the man 1 meter.
Mm-hmm. Yes.
The new distance between the man and the mirror is
Yes.
4 meters minus 1. That's three
Okay. Makes
meters.
sense. You're making sense. Go ahead.
So the image, the new distance between the mirror is equal to 3 meters. Therefore, if if we if we if we calculate the total distance
Okay.
between the man and the image, it will be
Mm-hmm.
3 meters.
Good. Makes sense. Makes sense. I like that. I like that. I like that. Any person that is confused, do you have anybody confused based on this explanation you gave? I think it was quite detailed. Anointed is a
okay.
good teacher. I think it was quite detailed. Justice, you want to say
I
something?
understand that. Yes, I understand. I answered 3 meters. 3 meters was the distance from the man and the mirror, not the image on the mirror. Right?
Yes, the man from the mirror. Yes.
So it will not be
Yes, but
double 3 times.
yes, because always remember that image distance is equal to object distance. That means the one behind the mirror. Is that okay? So what you calculated as 3 meter is distance of the man from the mirror. Not, you get the point now. Yeah. So I'm glad you guys are picking up. Like, it's a very beautiful one, and I think this pattern is very good. I will not be answering much, so I just give you guys the key concepts, and then I will rest a little while and allow you guys to do the calculation. So they said two mirrors M1, M2 are inclined at right angles as shown above. Calculate the angle of incidence, calculate the angle of reflection of the ray of light at M2. Calculate the angle of incidence of the ray of light at M2. So this is an issue of mirrors being inclined. So we're asked to calculate the angle of incidence of the ray on M2. So who is trying this out? Anybody? Or should I go ahead and explain? Do I have brethren in the house that want to give it a try? Okay, Paul wants to give it a try. Meso, do you want to give it a try? Lillian, do you want to give it a try? Princess? That's why you giving a thumbs down. You're scared. Eh, I want the answer to come. Princess, say this B. Okay? Princess, what's your reason for saying that? Or before you give me your reason, let's wait for another person to produce the answer. Meso, don't be scared. Look at it and try. And what your challenge is that you're seeing the diagram for the first time. But don't be scared. Try. Look at it and try first. Look at it and use whatever thing you've learned so far. Paul said 60. Look at it and try. Look at it and try, guys. Titi Lola. Tina also said B. Okay, okay. No, so you're standing with Princess. Meso said C. Titi said C. Okay. Titi said C. Titi Oya, on your mic and explain. Nikki go said silver. Okay, before Titi will explain, Nikki, explain for your answer for B. Nikki go silver, over to you.
The angle given already was 30.
Okay.
So, and they say we should find the M2. I don't know. I just calculated the both of them and divide. Like I don't know how to explain, but
You use OU method. In Igbo language, you call it Mano method. Hmm? You use the Mano method.
so I don't know.
Okay, it's fine. Titi Lola, over to you. Tell us why your answer is 60, please.
Okay.
Titi, there's this sound. Are you using a headset? Are you using either a headset, AirPod, earpiece?
No, I'm not using anything.
But it's the only me that is hearing that sound. Do from her end. Is the phone on speaker?
Yes.
Can you remove just remove it from speaker so it can be better, eh? Remove from speaker. After
Okay,
the jam,
can
let's see
you
how good. After the jam, let's see how we can get a powerful device for you. They hope girls will contribute. They will do
thank
GoFunded.
you. Oh yes.
Why is it
Oh
only
yes,
the girls contributing, man?
Oh yeah, is it not girls for the girls? Are you not supporting yourself?
Boys do something, man.
Okay. Oh, right, go ahead.
Okay. No, I'm not sure if I'm correct. I'm not even sure if what I did is
Be
right. So I just
bold.
did 30
Have that.
times
See,
2.
when you see, let me teach you guys something. If you answer any question, and that's what mathematics gave you, be confident with it. Have that confidence. Even Nikki, your answer is 30. Be bold enough. Even when you use the manual method, be bold enough to defend your answer. Don't say I think. Right, go ahead.
Okay, I just did 2 times 30 and it gave me 60.
Why are you doing 2 times 30?
Okay, so we had this formula now.
Titi, I think you use the manual method, please. Which one you do 2 times 30 and you pick 60?
No, it is 2i. We had this formula, angle of I think refraction is equals to 2i. So I just used 2 times the I that I saw there and it was 60.
Remember that. Wait. Now, show me where that 60 is going to be. Is it here? Where will I put 60 on this diagram?
Let me check.
Oh, you didn't even check.
Well, it will be. Oh, sorry, that's not what I did, though. That was not what I
Titi,
did. I remember
you
what
use
I
the
did. Sorry,
manual.
this is what I did. This is what I did.
Okay.
You know, you said you do 90 minus the angle. So I did 90
Okay.
minus 30 and I got 60.
So I'm asking now, where is the angle for the 90? Where are you getting the 90 from? Like, which side is that angle being represented on this place now?
Okay.
That's what I'm asking. That's the only way that will show you like you didn't use oil method. What do you call
I
manu in
know,
Yoruba?
try.
What do you call oil in Yoruba?
God, I beg.
Paul.
Okay, so
I know she will not know. Don't mind her. Paul. How do you call oil in Yoruba?
You don't know.
Eh?
Ororo.
Oloro.
Ororo.
Oyoyo. Type it, please.
Ororo, not oyoyo. Ororo.
Oyoyo.
ORO.
O-R. Ah, this one suits me. You are using Ororo method. Even a sweet passive yourself. You are using Ororo method. This
Let me
one suits
try,
me. Ororo method. Oyo method. Ororo. That's the method. Okay, Titi. Who else want to try?
So I think the angle, is it the 90 where you're asking that where we put it, or the 60?
Yeah, I'm asking there. Explain it based on this diagram. Explain your 60 based on this diagram. To tell me you understood it.
Sir, can I
I
answer?
understood it.
No, don't worry. Just
Seriously,
raise your
I
hand.
can't explain.
Okay, don't worry. That is Oloro method actually. That's but your 60 is the answer is 60, but what you use is Oloro method to get the answer.
It's not Ororo.
Good.
I should know that I did 90 minus 30.
That's the 70, but you cannot explain based on the diagram. Now, who again chose an answer here? Princess Mwije, that's an Igbo name. So Princess, you said B. Then come and explain. Let me know whether you use the Mano method. Igbo people is a Mano method. Yoruba is a Oloro method. So let me see. Oh yeah.
Okay, so
Princess.
okay, so like I just have a shallow knowledge of
You are speaking phonetics. I
like
cannot hear
weights
you.
and all.
What I'm
So
hearing? Do you know what I'm hearing?
I just
Are you holding your nose?
no. Okay, let me just go
Okay.
to this point. So like
Okay.
where 1 equals with 2 equals with 3. So I was like since the angle of incidence was 30, I just thought, okay, since where 1 equals with 2 equals with 3 because it's reflected, maybe it should be B.
Okay. Thank you for that Mano method. I love your Mano method. Justice, over to you. But you are doing well. That's a proper explanation anyway. Justice, over to
So
you.
I want to say something.
Okay, Manuel, over to you.
So here we are asked to find. This is a scenario whereby we have two mirrors and the
Okay.
right ray is reflected from the two mirrors. But
Okay.
what we are asked to find is the reflection on the second mirror, which is M2.
Yes.
Then on that second mirror, then if you divide it as angle 90, you will be able to find the angle of incidence with the angle
Okay.
theta below.
Good.
When if
Sorry, we lost you. I can't hear you. We lost you, Manuel. Can you guys hear him?
so I'm back. I'm back.
Okay, yeah. Go ahead.
Since the incident angle is equal to the angle of reflection on that M2 on that second plane mirror, so then on the M1 the angle of incidence is 30. So then likewise on M2 the angle of incidence should be 30. So,
Teaching good, sir.
so, so that's why I said B.
Good. That's why I said was B.
Yes.
So the answer is 30 degrees.
Yes.
Yeah, you have a very powerful concept right there. That's why I was shouting teaching good, sir. Right? In as much as your answer is not correct, the 30, but then you have a powerful knowledge of what I'm saying. That's what I want to hear from them. Titi and the rest of them that said, now, Mesa, you want to now finish the work that someone started. That's what Mesa wants to do now. Because it's remaining very small. And Mesa, go ahead and finish the work. Now score the goal.
Okay. They gave us the incidence rate to be, that is M1 to be 30 degrees. Therefore, the angle of refraction of M1 is also 30 degrees. But we're asked
easy. Let's put the values in, right?
Okay,
so now this is 30. It also means that the reflection here is also 30 degrees.
Yes.
Good. Continue.
But we're asked to determine the angle of mirror 2.
Yes, that's a reflected ray from M2, yes.
Yes. And remember that these two mirrors, they meet at an angle of 90 degrees.
Okay.
and their normals are also at right angle to each other. Check
Okay.
it. Check the
Okay.
image. Yes.
Okay.
So,
It could be brutal.
so
Go
if
ahead.
the
Go ahead.
ray, okay, if the ray make an angle theta with the normal of the first mirror, that is that line that
Okay.
I just drew now.
This one.
Yes, it will strike the
Okay.
second mirror at an angle 90 degree
Okay.
minus theta. So
Okay.
that theta now is 30 degrees. So the what we're gonna do is 90 minus 30 to give us 60
Okay.
degrees.
Okay.
So
Power.
the angle of
Somebody.
M2 in this
Okay.
thing is 60 degrees.
Okay. Now, alternatively, somebody say power. Right. I like the way you guys are thinking now, right? Now, another thing we could do, look at these things now. Another thing we could do. I love the fact that from this one, incident ray is equal to reflected ray, right? 30-30, isn't it? Based on law of reflection. Now, this same ray hits our mirror here. Remember that we have this line here. That's your normal, right? You have the normal there. Now, that said, remember your mathematics. If here is 30, this is a line. This is a line here. What would this place be? 30 degrees, isn't it? Now, alternate angles. So now, if here is 30, what would this place now be? What would this?
60,
here now
60.
So now,
Yes.
what will your reflected ray be? Because they are equal. 60 degrees.
Yes. Yes.
Are you seeing it now? So it's just direct, or you can use the pattern Messer used by saying that here, Messer said that if you join this line together, that here is going to be what? 90 degrees. Isn't it? That what she said. So if that place is 90, 90 plus 30, you now have a right angle triangle, 120. Isn't it? You have a rectangle triangle. Good. So you have here is 90 plus 30. That will give us what? 120. Total angle in the triangle, you get here to be 60 degrees. So therefore, here as well will be 60 degrees. Do you understand? So anyone that is convenient for you that you want to use will give you the same answer. Are we all on the same page now? All right. So all the best, guys. I enjoyed today's class, and I hope you enjoyed today's class as well. It's quite interesting. And all right. And then I'm glad that you guys are following through and you understood whatever thing we did today. First off, I think I'm proud of myself because I was so tired. I was thinking about postponing this class, but I'm glad that I did it. As I'm so excited I did it, right? 2 hours plus, right? I'm glad I did it because I wanted to move it to the night because I was so exhausted from the stress of weekend and everything. But I'm glad I did. And I'm very happy. Not that I just taught the class, but I'm glad that you guys actually answered it. And I like the logic. I like the Roro method. I like the Manu method, right? And all of those methods are very good. So anyone that works, right? So I advise us to solve more questions. Well done, Nikki. Well, Sana, because you come. Sana, because Nikki, what do you want to say? That you want to say? Sana, because you come the chop join. How do you know? How do you guys know I was eating?
So it was obvious.
It was very obvious.
I wanted to ask you when you were talking that time. Really, it was already watching something.
Yes, now you guys are answering questions now. I'm not teaching you guys are answering questions, so I need to get my mouth busy a bit now. Huh?
You did not bother to call us to join you.
Hope it didn't affect your understanding at all.
It enhanced it.
Yeah, right. I know Nikki likes food. That's why she paid attention to the sound of my food. Nikki likes food so much. Me, I know. Right? Me, I know. All right, guys. I'm so glad that we follow through. So in our next class, I'll be looking at reflection. If not for one thing, I would have said, let me do a nice class. But then once it's 3:30, I have a class till 10 p.m., right? So that will be a bit stressful for me. So we would have looked at reflection by curved mirrors, right? But I promise us that we start in our next class, which is on Wednesday. We'll look at reflection by curved mirrors. We looked at plane mirrors. We're going to look at curved mirrors. After that, I think I will look at refraction as plane surfaces, right? One key thing is that even after the boot camp, the boot camp is ending on Saturday, which will be your last English class. And after that, no English again, no chemistry again, no biology again, right? Yes, that's my class, 3 to 10 p.m. Yeah. Not one class, different classes with different people actually. So that's for that. So at the end, the only thing you are going to do is to go to your dashboard and watch those video lessons that, thank you, Anointed. Watch those videos that have been uploaded on your dashboard, right? All of those things have been uploaded. But then you still have me. I'll be showing up every day till you write your exams, right? So the exam starts on 26th. I'll be showing up every day, right? You still have me. So it's entirely fine. And I'm glad you had a wonderful experience in the boot camp with the teachers and everyone. They miss you as well. Yeah, they sure do miss you guys. All right. So all the best. You have your, I think, biology class now, isn't it? I don't know when your exam is starting. Anytime it starts, that's when I'm going to stop. Yeah. So all the best. I'll miss you guys. Yeah. All the best. And I'm sending the this into the group, and let me off the recording. Please solve more questions on this. Solve more questions on this. All right. We'll miss you too, Mesho. You guys have your contacts now. Collect your contacts and connect with each other. But the boys will stay clear. Focus on your jump. Don't collect any number. All right. All the best, guys.